The important 3-omega fatty acid, the one that is in clinical utilization, is something called DHA. And DHA as a specific molecule, especially in the brain, especially in nerves, there's a very, very high concentration of DHA.
Yes.
Right at the end of the nerve, the area called the synapse, which are where the two nerve endings come together and the signal, the electricity.
No, Rob, it's not electricity. Nervous signals are not electrical. Not at all. Wrong. Again.
Jumps across that synapse through.
It's a chemical signal, not an electrical one.
Chemical mediator, acetylcholine.
Yes, chemical, not electrical.
For example, is a mediator that jumps it across that that nerve ending. So electricity flows.
No, it is not electricity, Rob. It is a chemical concentration gradient message. There is no voltage. None at all. So you don't even understand this most basic it's called electrophysiology, completely inappropriately. And often the resting membrane potentials are referred to as voltages. They are not voltages, Rob. There is no voltage across the membrane. The voltages that are being read by voltmeters are created by electrodes. It is a conversion in currency between a concentration gradient situation, which is what you do have in nerves physiologically, and that difference in concentration gradients is transmuted into an electrical signal at an electrode so that it can be read by a voltmeter. That doesn't mean there is any voltage or electricity in a functioning nerve, in a living being. There isn't, Rob. Take the electrodes off and put bare microwires across a membrane with a voltmeter connected in series, and you will find that the voltage is dead flat zero. It is not electricity. Okay? You've learned something about so-called electrophysiology today, I hope. What's next?
Down, has to jump the gap, arc across that gap.
It's not arcing. Arcing is what electricity does. Human nerves do not transmit electricity at all.
And then follow down. And that happens in milliseconds. And one of the things that's important to synaptic transition, there are many things that are important, but right at that synapse, like my fingers are over here, those are DHA molecules that are inserted in very high concentration, specifically at that synaptic junction. And they are...
Yes, but so what?
Fatty acids, they're polyunsaturated fatty
No, they are fatty acid anions, not acids, Rob.
Acids that are inserted as part of the phospholipid membrane.
Yes.
And the thought process is that those DHA molecules in high concentration allow a rapid arc of the
It is not an arc.
Message across that synaptic gap. So think of them as like hot wires.
No, don't, because that would be wrong, Rob. Totally, completely wrong. False analogy. Goodness me.
That allow that electricity to...
It is not electricity, Rob. No.
Go across through the acetylcholine, trigger that and go across. The other thing that they need slightly further back on that synapse is a high concentration of mitochondria. And the high
This is irrelevant also to the DHA situation, Rob. This is just yet more noise.
Concentration of mitochondria produce the energy that allow that spark to jump across.
It is not a spark. It is not electricity. It is not the movement of electrons. Wrong. Completely wrong.
So when you look at nerve endings, we need the DHA right at the nerve ending, and we need those mitochondria.
You've said both of those things. Let's move on.
And folks, you notice the word I've been using is specifically DHA.
Yes, we did notice.
And there's a high turnover of that DHA in the human body, so it needs to be, can be stored.
How high, Rob? Show us a paper that talks about the turnover.
But it needs to be supplied to the human body. And
yes.
Here's the interesting thing that I learned, because the thought process is that what we need is high concentrations of the precursors.
No. Nobody who knows anything about human physiology has known for years and years and years that that is false. The human capacity to transmute ALA into DHA EPA is near zero. You must get DHA in the form DHA, and the only place you can get that is from eating animal flesh. What's next?
The alpha-linolenic acid, the linolenic acid. See how bad I am with this terminology.
Not just the terminology, Rob, you're also pretty bad with the physiology, as I've pointed to several examples of already, and there's more coming.
But that those precursors are then rapidly used by the liver and by the human body, by the cells of the
False.
body to make DHA.
False.
And that's wrong.
Yes, that is wrong. And as I say, competent nutritionists such as myself, Rob, have known that for more than a decade.
That's wrong.
You said that already.
That's wrong.
Goodness me, there seems to be a problem with your electrical nerve transmissions in your brain, Rob. Did you trip over when you were young and hit your head on a record player, but you're all right now? All right now. All right now. All right now. Are you? Good. Can we move on?
The human body does not have, the human liver does not have the capacity.
Yes, and this is a bloke whose PhD is apparently in liver function, and he didn't know this. Incredible, isn't it, boys and girls?
To produce adequate volumes of DHA fast enough.
This goes to show you that a PhD actually, all that is it means that you know a great deal about very little. They are so specialized and so focused on such a small area that actually they really don't add any utility to someone's generalized knowledge of physiology, nutrition, or anything else, or medicine, or any field that you might be working in. Do they, Rob? Didn't know this, Rob. Why didn't you know this? Well, I'll tell you why you didn't know this, Rob. Because you are not a nutritionist. Okay? And as such, should not be talking to people about nutrition. You are out of your lane.
From their precursors, that if all you ate was the precursor, you wouldn't have adequate DHA
And that's one of the reasons, one of the many reasons why veganism is a mistake.
in your body. And that is a crucial concept to understand.
Yes, it is. And we've known about it for more than a decade, Rob. You haven't, clearly.
I know this is high science.
But no, it isn't. This is pretty basic stuff. It's pretty straightforward to understand this. We don't have the machinery to interconvert those fatty acids. That's not high science, Rob.
But here's where I made a mistake, folks.
Yes, you made a mistake by thinking yourself competent to talk to people publicly about nutrition. That's the mistake you made, Rob.
Here's where I made a mistake.
Again, with the repeating yourself.
I bought into the concept of 3 omega fatty acids and the ratio of 1:1, 1:3 of 3 and 6s, and we blamed the 6 omega fatty acids for all kinds of harm at a ratio of 30.
Right. Because you are not a competent nutritionist.